Welcome to our webinar this afternoon. Before we start, just some housekeeping. If you have any technical issues, please send a short message in the questions box on the right-hand side of your screen. During the webinar, RSSL would like to invite you to ask questions using the question box, which is also on the right-hand side. And at the end of the webinar, time permitting, we will try and answer as many of these as possible. Any we don't get around to, we will answer offline and share with you all, along with a link to the recording. Today's webinar is on environmental monitoring, how to carry out less testing and still maintain compliance. My name is Mark Igbedian. I'm the Biologics Sales Manager at RSSL. I recently joined the RSSL team and have worked within the pharma and biotech industry for over 15 years. My role is to support our clients that require a variety of microbiological and biological testing, from environmental monitoring through to protein characterization. For those of you who are new to RSSL, who are we? RSSL is a global CRO supporting clients with a wide range of variety of analytical services. We've been around for over 35 years and are based exclusively in the Reading area, where we have 4 separate sites. For those of you who don't know where Reading is, we're about 40 minutes west of London and Heathrow. Our 4 sites accommodate over 350 scientists working and supporting clients in 12 different technical areas, of which microbiology is just one of them. We support clients globally, with clients all around Europe, as well as the US and as far away as Singapore and Australia. RSSL is a trusted CRO with a big emphasis on quality, science and service. This can be shown through a high Net Promoter Score. Because our sites are close to one another, we can show great agility to manage complex multidisciplinary projects. We also have a dedicated multi-lab product manager and client liaison managers to ensure those complex projects are kept on track and managed. The 12 technical areas we specialize in allow us to support a diverse range of biological, microbiological, chemical and physical analysis services across all phases of clinical development through to commercial release. We're exceedingly well positioned to support your projects, utilizing our state-of-the-art equipment and experienced technical team who can advise and support you throughout your manufacturing. Be that routine raw material testing, investigative support of any issues you may face, such as impurities or foreign particles in your processes. We have a well-equipped and extensive microscopy department which can build a specific particle database for your manufacturing process. Our microbiological support is also extensive, where we can support all aspects of your Annex 1 compliance, including microbial identification of any EM isolates or unfortunate positives from your bioburden analysis using our state-of-the-art MALDI-TOF system. We can also offer a range of turnaround times to ensure you get those ideas through as soon as possible to help support your decisions and next steps. Enough of me. I'd like to now introduce your guest speaker, Dr. Tim Sandle. I'm sure many of you are aware and heard of Tim and subscribed to many of his publications. Dr. Tim Sandle has over 30 years experience of microbiological research and biopharmaceutical processing. Tim is a member of several editorial boards and has written over 900 book chapters, peer-reviewed papers and technical articles relating to microbiology. Tim worked for a pharmaceutical manufacturer in the UK and also finds time to be an associate professor at both the University of Manchester and UCL. Over to Dr. Tim Sandle.
Okay, thank you very much, Mark. So just switch over my screen. And Mark, can I just check you can see my screen okay?
Yeah, that's correct.
Okay, brilliant. Okay, well, welcome everybody. It's nice to be back with you for another webinar. And you may have heard previous webinars that we've done before looking at environmental monitoring. So we've looked at method selection, we've looked at risk assessment approaches, we've looked at things to do with the actual data. And with this one, we're kind of continuing that theme, but we're now looking at a more mature and established environmental monitoring program. And this is the kind of sense check, and to make sure the environmental monitoring program is fit for purpose. So we're going to be looking a bit deeper about how we might want to select locations. So we're going to be looking at the application of hazard analysis and critical control points. We'll also be looking at determining frequencies of monitoring through the application of risk filtering. And then we'll be looking for the fully developed program where you've had monitoring in place for a number of years, and now it's like, okay, is every location adding value? Can we save some time and money but still remaining on the right side of the regulations by eliminating some samples? And how might we want to do that by adopting a data-driven approach? So that's the kind of main thrust of the webinar. But before we do so, we should consider risk in itself, because I think it's always useful to remind ourselves about the terminology and some of the things that we're trying to achieve. So what do hazards mean in the pharmaceutical and microbiological context? Well, a hazard, which is the basis of risk, so you can't weigh up a risk without identifying the hazard. And the hazard is something that has the potential to either cause harm or to give us something that is unwanted. So the steps in risk management is to apply a formal tool to enable us to carry out risk analysis, to identify and to weight and group hazards. Then it's about risk control. So what can we do to minimize the likelihood of that hazard occurring? So what kind of actions can we put in place? And then it's about assessing the hazard. After we've attempted to control it, what's left? And then we're into what do we need to monitor and how do we communicate that outwards. So with environmental monitoring, it's very much about finding where microorganisms can come in, they're the hazards, what the different vectors are, where they can be spread or transmitted, how do we control that? And then when we've narrowed things down and what we're left with are the more important, meaningful locations, then we move into detection, which is the environmental monitoring. But as I've said many times, environmental monitoring is not a substitute for environmental control. So we need to reduce hazards, maintain control, and then monitor. There's no point having weak controls and just performing lots of saturation monitoring to try and make ourselves feel good. So the types of origins of contamination are going to relate to certain bits of equipment, how that equipment is operated, how it's cleaned, how it's maintained, how it gets into the clean room, the air within the clean room. So that's going to be partly a product of the filtration, partly a product of the air movement, and then with the deposition of any contamination into the airstream. Then there's people, and we've said many times before, people are the primary source of contamination within the clean room, and there's going to be variables about the way people behave and the quality and use of their gowns. And then, of course, where we have clean rooms with water, we're dealing with a double scenario because water is a source of contamination, so microorganisms could exist in water. It enables microorganisms to grow, and also it's a fairly effective vector through aerosols about distributing contamination around the clean room. But even once we know the origin of these hazards, we still need to understand then how could the hazard actually then make an adverse impact on product, which is always our primary concern. So the risk from microbial hazards normally requires some form of act of transfer. So we always going to have a series of steps, so people can touch things. Water we've mentioned with aerosols, air with its direction, or the way that materials enter the facility is another area that needs considerable attention. And then the likelihood of the contamination getting into the product is going to relate to how much there is, where it is, how it's likely to move into the area where the product might be exposed, and then what's the likelihood of that being retained. And all of this fits into the contamination control concept, specifically the biocontamination aspect of that. The risk assessment and environmental monitoring are two paths into our understanding of the overall biocontamination control strategy. So we can use these tools to help us plan to reduce microbial contamination, risk reduction steps, and then to decide on monitoring. Okay, so with that background, we're going to look at the first of the three areas I've selected as part of this theme to try and get ourselves to have a meaningful, targeted, non-excessive environmental monitoring program. So the first thing we're going to have a look at is this risk tool called HACCP, or Hazard Analysis Critical Control Points. And the origin of this tool goes back to the 1960s, when it was first introduced into the food industry to look at ways to stop cases of food poisoning. So it was understanding process flows within large industrial kitchens, and it led to things that we now accept as fairly common today. So the idea of having one chopping board for meat and one chopping board for vegetables, for example. This was then picked up by NASA and was introduced into spacecraft assembly, and then has frittered its way into pharma. So HACCP is a systematic, proactive and preventative method, and it seeks to identify risks that we'd face in the pharmaceutical context. So what we're looking at today is microbiological, but we also have physical, chemical and other biological hazards. And what it's trying to do is to process map the clean rooms, the operations within those clean rooms, and then to look about where hazards could originate, and then what's the chance of those hazards impacting on product or anything else we might deem to be critical. And once we understand where they are, then those critical points then are justifiably good sources for environmental monitoring. So the general approach, the sort of stepwise approach, is to conduct hazard analysis. So we're seeking to identify preventative measures for each step of the process. To also then determine critical control points, these are the monitoring points, to then establish target levels, appropriate limits, establish how often we will need to monitor these for, and then also to start doing some pre-thinking and say, okay, if we do get results of high bioburden levels, we're getting results that are exceeding action levels, what steps do we want to take in order to try and mitigate those should they occur? And then there's also the importance of continuous verification, continuous improvement, where you want to constantly check that the system is fit for purpose. We are monitoring in the right locations. We haven't had the room redesigned, new air filters fitted. It's all about that ongoing suitability. So as I said, one of the primary uses of HACCP is this concept of developing a route map. So in simple terms, the parts of the facility are drawn out these days. A lot of people have access to computer-aided designs and things, but even if you haven't, even sketches to a degree are suitable. And And then it's understanding the route, the flow in of product, the path that people take, how long people will stand in a particular area, what things they're likely to touch, where is product exposed, where is product open, and so on. And then understanding that helps to orientate us towards a more meaningful environmental monitoring program. And you can only really approach this by walking the area. So one of the common terms in pharma these days is gemba, which is a Japanese word. One of the uses it was common in like the Japanese car industry, and it kind of roughly translates to go to the point of pain or go and visit the area. So you can't really conduct a risk assessment from your office, particularly in this context of environmental monitoring. You need to go and walk the floor, understand, see with your own eyes what's happening. So where are people, where does material go, where does waste come out, where is product transferred? And you can also use environmental monitoring data that exists as well to help with some of those points. The locations may or may not be where you ultimately really want them to be, but it's useful background information. So in terms of like the monitoring locations, these critical control points, then it's partly about defining what level of risk warrants monitoring. So if you end up with some high risk points, some medium risk points, and some low risk points, then the low risk points, in theory, if they truly are low risk, probably don't require monitoring, whereas the medium risks will at a certain frequency and the high risks will at an even higher frequency. Then you need to decide on what's the most appropriate monitoring type, and that's going to depend upon the possibilities or the various routes that are available for contamination to be transferred to somewhere where it is originating from to somewhere where you don't want it to end up. So it might be that you're just worried about surface level cleanliness. So how high is it here? Is there a chance that people put objects down or operators' hands might touch? And then is it being transferred elsewhere? Or is air or water our key concern? So there's various thoughts to kind of weigh up there. So if we take an example, so what we have on the diagram is two pictures of the same room, just that one of them is positioned in a landscape style and one of them is in a portrait style. But it's a room, it's a grade C clean room, which contains a number of processing vessels, pipework, and so on. And the green arrows are referring to the route of people coming in, and also the way that additional consumables and excipients for the process would also come in. And the red arrows are the way out. So looking at that in this particular example, then some environmental monitoring locations have been considered, and they're partly reflecting the route and partly affecting the concentration of people, and also partly reflecting where one of these vessels is opened up and where material might be transferred in. So this is just purely illustrative. Again, with a lot of these things, it's been able to come up with something that you can defend, that makes sense to yourself, to the management, and to auditors as well, so that when you're recovering, or hopefully not too often, but when you're recovering problematic environmental monitoring results, or you're recording environmental monitoring results above action levels, that you have some way of saying, yep, okay, I understand why that is, I understand what risk that might be presenting, I understand the significance of Okay, so we're going to move on to the sort of second example, and this is to look at monitoring frequencies. So because we now, in the previous example, have something that's guiding us to appropriate locations, and with the identification of those hazards, it doesn't mean that every space in the facility, every type of clean room warrants the same level of monitoring. We can develop a more nuanced approach based on the particular environmental characteristics of that room. So if we have 30 grade C clean rooms, we don't necessarily want to monitor all of those clean rooms at the same frequency. Some of those rooms are going to be used for direct product processing, others might be storage areas or access corridors or buffer preparation or something like that. So we need to kind of have a rationale if we want to have variable frequencies. And the reason we may wish to have variable frequencies is, one, it's communicating to regulators that we have a good level of process understanding, and two, it's helping to save process time and resources. And most facilities won't have infinitely large microbiology departments that can have hosts of people who can continuously go out and take samples, process samples, read samples, perform identifications, and then even if we did, we might be deluged with data. So we need to keep all of that in balance. So the method we're going to have a look at is, again, a risk-based method that's partly based on risk ranking and risk filtering, and it's adopting a process where you look at the severity of the risk and the probability or likelihood of the risk occurring, and then also weighing up what different detection methods are at our disposal. And this one is, it's not strictly FMEA, as in failure modes and effect analysis, but it has some parallels with it. So there again is sort of a common framework with all of these kind of risk tools. Are asking fairly similar questions. It's just how we choose to express those that can vary. But here we want to sort of weigh up risk identification. So, what are the risks? And then with risk ranking, this is about, okay, we've got a list of risks, but how important is each risk in context of the other risk? And because some risks are going to be greater than others, but you can only really look at that in context. And the way we can achieve that is through risk filtering. And then we can perform our overall risk assessment. So again, in terms of trying to set the frequencies, it's important to understand the clean room operations and to consider, what could cause microbial proliferation, what could lead to high numbers existing in the first place and then remaining in the environment, and then what's the possibility of microorganisms affecting the manufacturing of the product. So the objective here was to come up with some kind of numerical score that would allow different clean rooms and their relative risk to the product to be compared with each other, which would then allow different frequencies to be adopted. And to a degree, how often or how we set frequencies of monitoring is going to be partly something that relates to what data we currently have, what trends are like, what our action level excursions are, but also, we need to be realistic about what our resources are. And I know that that's frowned upon in certain parts of EU GMP. There should always be the right number of resources available in order to deliver and assess quality, but in reality, every job in pharma is a cost, and every laboratory is only going to have so many staff. And then there's the cost of taking samples, processing samples, generating results, and then dealing with those. So in this situation, and this is a hypothetical situation, it's a non-sterile facility for this example. So we've got some proposed monitoring frequencies, which we're going to call 1, 2, 3, 4, weekly, fortnightly, as in every 2 weeks, monthly monitoring, and 3 monthly monitoring. And these are arbitrary. You know, if you wanted to have daily monitoring instead of weekly monitoring, change fortnightly to weekly, or extend out. I mean, it's whatever fits. But in this case, these are the frequencies that are adopted. And the next thing is some kind of basis to allow us to score. So this is to set some scores for severity and probability or likelihood. And this is to help us to decide what might make something a lower risk consideration, a medium risk consideration, or a higher risk consideration. And again, any such scoring is slightly subjective, and again, it's something that could be adapted as necessary. But in this illustration, these were the scores that were selected. Then as to the significance of those scores and how severity and probability relate to each other, then this diagram gives an indication of that relationship in this context. So we have severity running horizontally. So we have constitutes a low score, what constitutes a medium score, and what constitutes a high score. And then we have probability running vertically, and similarly low, medium, or high. And then you can see where severity and probability meet. We end up with different levels of risk that I've called here risk classes. So risk class 1, which is the red squares, captures high severity and high probability events. Risk class 3, which are the white squares, capture low severity and low probability events. And then in the middle, with the sort of bluish cyan squares, we have the medium events. And you'll see there's a slightly greater weighting towards probability. And the reason for that is, you know, we can always have risks that we might consider to be high, but it comes down to slightly more important is what's the possibility, likelihood, probability of those impacting product. Okay, so with that framework established, we need to consider the different risk factors for different clean rooms. And we're going to have different clean rooms used for different purposes based on different designs and different usage. So we need to weigh up, you know, what factors are we going to be most interested in? What are the things that can influence microorganisms being present and microbial survival? And to a degree, there's a degree of professional judgment in this, but there's equally a connection to science as well. So here's a list of risk factors. So to me, these are some of the key things that we would want to evaluate. So we have temperature, we have areas that are wet or dry, areas with or without water sources, areas where we're conducting either open or closed processing. We're going to be using rooms for different lengths of time. We're going to have different numbers of people. We're going to clean and disinfect at different rates. We're going to have some rooms that are upstream, some are downstream. We're going to have some where the equipment's fixed in the room, others where the equipment's going to be constantly taken in and out, perhaps for manual cleaning. And we're going to have the context of the environmental monitoring history of the room. So the time available, we're going to have time to go through all of these different risk factors in detail, but I'm going to illustrate the temperature one and then briefly talk about the others. So if we look at temperature, we're going to have rooms in the facility, depending on our process, that are running at different temperatures. So we're going to have we may have freezers, we may have cold rooms, we're going to have rooms at ambient. We may have rooms that get a little bit warmer for different reasons. So we need to ask ourselves the question here, under what conditions can microorganisms survive and proliferate? So with a freezer, that's got the lowest outcome, a score of 0. And that's because freezing either will kill microorganisms, so it's a microcidal effect, or if it preserves, then at best it's microcidal, but a lot of microorganisms won't survive the freezing process. Under cold conditions, for the vast majority of microorganisms, this is going to be an inhibiting step. They're going to be microstatic state. There are obviously groups of organisms, so we could have psychrophilic organisms, highly unlikely, but we could have psychrotolerant organisms, which are organisms that do have a level of metabolic activity under cold conditions. Pseudomonas fluorescens is a prime example. And we can kind of judge this by understanding what our environmental monitoring data has been. How many times have we actually recovered organisms that we would classify as psychrotolerant from cold rooms. The highest rating is given to ambient rooms, and that's because if people are the biggest source of contamination, then the highest abundance of microorganisms will be mesophilic organisms. And equally, we want to give a fairly high rating to warmer areas. This might increase shedding. It's probably going to have a fairly similar profile. So we'd work through each one of the risk factors and come up with scoring systems. So if we just pop back to where we were before, wet areas will pose a bigger risk than dry areas because there's a greater abundance of different organisms associated with water, and it's also I mentioned before about being a growth source and a means of spreading contamination. And similarly, open processing is obviously a bigger risk than closed processing because there's more opportunities for microbial ingress. Duration of activity, the longer that people are in the room for, the greater the likelihood we're going to get a build-up, increasing concentration of airborne particles and so on. So we give every room, we go through different risk factors, and then we also need to consider our detection method. So detection doesn't mitigate risk, as I said earlier, but where we have better detection, then we can build up more information about the ultimate risk to product. So if we purely have environmental monitoring, then we get a partial picture. If we're able to take intermediate product samples in process material, then we have an idea of the likelihood of these microorganisms ingressing into the product, or we can see how similar they are to what we find in the room. And if we're doing things like adding ingredient water to the product, and if we can also ascertain water quality, then again, we're building up a more detailed picture of the risks that are presented to the product at the end of the day. Okay, so it's a little bit abstract. Let's have a look at an actual example. So here we go. We've got an imaginary clean room that we're going to call P100. It's a grade D room, and it's used for preparing equipment prior to autoclaving. In this case, it's a sanitizing autoclave to go into a grade C area. So we've got the factors that we were looking at previously, and we have a set of scoring outcomes. So the room is ambient. So that gives a score of 3 under the severity rating. It's a dry area, so the probability of microorganisms being present is lower than if it was a wet area. So it gets a score of 1. There's no drain in there. So we score that 0. It's not a room that's used directly for processing. We score that also as 0. But the room has high level of human activity. It's used for long periods of time, so that would score higher. Because it's a grade D room and it sees no direct product, it's not on the highest cleaning and disinfection frequency. So again, it's going to score relatively high. It is quite a way away from the formulation of the finished product, so it would only get a low score for that. Although it's used for prolonged periods of time, it has a relatively low occupancy at any one of those times. The equipment is fixed, so it's not going constantly in and out to be cleaned and brought back in again. So again, it would score a bit lower. The environmental monitoring history is good. So again, we're scoring that low. So we end up with, at the end of the day, a severity score and a probability score. And in this case, our severity score is 8 points and our probability score is 9 points. So what do we do with that information? Well, we go back to the matrix that we had and we look along for the severity score, look along for the probability score, and we plonk the room into the box that is relevant. And we can see from that that it's a risk class 2 room. But we also need to take into account what the detection methods are. So to understand the detection methods, we need to go to a second matrix. So with the second matrix, we are moving to something looking like this. So we've got the risk classes running vertically, 1, 2, and 3. And then we have different detection methods running horizontally. So remember we were saying earlier, if we're just doing environmental monitoring, we get a certain level of information for doing environmental monitoring, but we can also test some kind of product material, or there's something that we can sample. In this case, we can periodically swab the material going into the autoclave, so we get an idea of its relative cleanliness. And if we had a water sample as well, which we don't in this case, we would have even stronger detection. So we can then position the room in this particular location, and then we can also then consider what would be the most appropriate monitoring frequencies. So remember the monitoring frequencies we were looking at the beginning. So we had CV1 represented weekly, CV2 represented fortnightly, CV3 represented monthly, and CV4 was a 3-monthly monitoring. We have our room in its location against an appropriate monitoring frequency. And then if we start doing that with all of our grade C clean rooms, we end up with different patterns, different monitoring frequencies, but we've got a basis to those. We've got a rationale for those. We've got some tangible information. And we also start to see a pattern in terms of the outcomes. So if we've got a large facility, we've got lots of different rooms, we start to see that the lower frequency of monitoring are freezers, storerooms, cold rooms. Medium frequencies might be rooms that don't see products, they're still important, but less impactful, wash areas, airlocks, changing rooms. Slightly higher frequencies are those with high personnel traffic, so corridors and storerooms. And then the highest frequencies of monitoring are going to be where products handled, where products exposed, going down towards more frequent, closer to final formulation, and then when we've got poor environmental monitoring data. Now, you might say, okay, all this looks like fairly obvious, and to a degree it is, but what this approach does, what this tool does, is it provides a systemic approach, something that we can justify, that we can show a degree of logic over. But it is important to keep reviewing, and reviewing this kind of information once a year is important. So has the room use changed? Have the parameters changed? Like, for example, have the air exchange rates decreased? We altered pressure differentials. And then we also need to consider whether the room has been redesigned. And also, of great importance, has the environmental monitoring trend changed? Has it become better or worse, or and so on? And then, if you're interested in reading more widely, there are some papers that relate to these things that I've spoken about, which I've written, and I'm sure we can find a way to sort of distribute those through RSSL. So if you need those, if you drop the organisers a line, and we can work that out. The final part is, now we've got this mature system, and we want to consider removing locations. So, we've been monitoring for years. We might do 10 samples in a room. Can we bring that down to 8? How do we do that without facing regulatory audit criticism and doing things that's actually effective? And this kind of feeds into sort of the lean laboratory approach. And pharma's under increasing costs, and we're always being looked at to save money. And it's not just an economic thing. We want to have an environmental monitoring program that's meaningful and is adding value. Then, it's again a part of that thing of building up knowledge and having the right information available. So we have locations, which we looked at in part 1. We have frequencies that we've looked at in part 2. And this is now sample numbers. So the approach I'm going to take is probably not suitable for aseptic processing. That might need a slightly more sophisticated approach, but it is readily usable for grade B, grade C, grade D areas. So it's kind of a series of steps. So first of all, we need to go back to our locations of monitoring. So we've picked our locations of monitoring. We have an idea about what kind of information are they telling us. Are they directly informing about high risks? So if we're taking a saddle plate really close to where we have an open vessel and we're worried about trying to pick up a vector of contamination or something getting into the vessel, then it's highly unlikely we'll ever want to consider that sample for removal. Other samples are going to be some distance away. They might just be spot hygiene checks. They're never showing anything. And these are the kind of samples that we can consider for elimination. And there's different ways to assess that. On the screen there, I've just got one way of doing it. So it's based on how close we are to the critical area, the ease of contamination transfer, and then I've just grouped samples into A, B, and C. And it might be something that we want to start with the C samples to see how we can remove some of those samples. So we want to consider the samples that are not necessarily giving us direct information about product quality. And I think it's also important that the samples that we're going to be considering would not have recorded any results over the action level in the past 12 months, because particularly we've got ongoing investigations, we should have to leave those alone. So we're talking about samples where we've seen counts below the action level or without any problematic trend for a reasonable period of time. And what we're seeking to do, we're going to be looking at data distribution. And what we want to understand is the data profile for the clean room. And for this, we can use histograms to make those comparisons. And then we want to see if we were to take out a location, is that going to significantly alter our data distribution? So has the microbial profile changed? And the histogram is a good tool for that, because it's an estimate of the probability of the distribution of continuous variables. So it kind of gives some dynamic data that allows us to make that evaluation. So if I'm going to summarize, roughly what we've weighed up, what was the risk assessment for the sample? Is it a low risk sample? Yeah, okay, then we should proceed. What's the alert and action level history for that sample? If it's good, let's proceed. Then we'd want to group samples of a similar type together. So we take all of our saddle plates, all of our active air or contact plates, and we'd construct a histogram of that sample type. Then we'd return to the data set. We'd say, okay, which samples do we think are sufficiently low risk, which have sufficiently good environmental monitoring history, that we wish to take out? And then we're going to ask ourselves, how do the two histogram profiles compare? And if the histogram having the sample that's been taken out shows a bias towards lower counts, then we've probably taken out the wrong sample. If it's unchanged or continues to show its bias towards higher counts, then it's probably something we can consider removing. So we're going to look at a grade C clean room. We're looking at active air samples. There's 4 active air samples taken in this particular room. We're looking at the range of microbial counts, and in histogram language, we're grouping those into what's called bins, so like the buckets of similar counts. So this is our data profile. So it's a given room. These are the air sample results over 1 year. You can see there that nearly 450 of those results are 0. There's around 50 that recorded 1 CFU, around 30 that recorded 2 CFUs, and then it trails away. And then if we take one of those samples out, so this is air sample location number 4. If we go to the histogram, then you automatically see that the frequency is shorter. We've now got about 330 samples at count of 0, but roughly a similar number that are giving other counts. So that's already signaling to us that the data that we have withdrawn, that particular sample, was probably made up of mostly 0 counts. So it's the other locations that tend to recover microbial counts within this clean room. So in actual fact, the frequency of samples recording 0 counts in this example has only dropped by about 1.4%. So we put the 2 histograms together, we can see that in this case of taking out this particular air sample has not really made any fundamental difference to our data distribution. So it's given us kind of quite a good overview that the data profiles have stayed the same. So this is just kind of one example that we can draw upon in order to show the significance of removing a sample. That is the main areas that I wish to cover. So just to recap, we've looked at selecting environmental monitoring locations through the application of hazard analysis and critical control points. So we're making sure that the locations that we're selecting are of greatest value. And then we've also looked at monitoring frequencies by applying something that's equivalent to failure modes and effect analysis and risk filtering. And then we've looked at data distribution as a way of seeing what the impact is of taking out a sample from a more developed program. So hopefully you'll see that these are additional tools that we can apply to a more established environmental monitoring program. So that's the main presentation. So I'll hand you back to Mark.
Thank you, Tim. Thank you for that information and comprehensive overview on environmental monitoring. We've actually had a number of questions come in. So what I'd like to do in the time remaining, see if we get some of them answered. So one of them is continuous non-viable and viable monitoring mandatory for sterile testing suites?
For monitoring sterile products manufacturing, if I've got the question right, then yes, it is. So under EU GMP Annex 1, it says that continuous monitoring for each stage of aseptic processing under grade A is mandatory, and it's advisable, which kind of really is a nod towards you should, for grade B. Now, what that means is continuous particle counting. Depending on the air monitoring method, continuous exposure of cell plates, or considering the newer generation of active air samplers that run continuously, and then taking surface samples at the end of the activity. But yes, it is expectation.
Okay, great, thank you. We have another one here on the frequency of monitoring. As far as very new and setting up, how can it approach environmental monitoring since there's no historical data?
What I would do would be to kind of adopt a similar approach to what I was looking at in the second one, because you will know a lot of information about the room. So you obviously you'll have a certain design specification, so we know what the class of HEPA filters are, what the room air change rates are, what the pressure differential is, and then we'll also have an understanding of the environmental conditions that room will run at. So we'll have a certain temperature, certain humidity, and then we'll have an idea of what's going to be taking place in the room, whether it's closed processing, open processing, whether there's a water source, and we should have an idea about personnel numbers. So we can do an indicative assessment, and then over time we'll build up the environmental monitoring history for that particular clean room. And with a new clean room, you should always start with a relatively higher level of monitoring and then scale that down. So all of this information will come together. So we'll have an initial assessment, and then we may want to do a secondary assessment 6 months or 1 year, and then make that modification.
Okay, thank you very much. I got another one here as well. Would a risk-based approach also likewise apply to a micro-characterization requirements for colonies obtained from environmental monitoring samples?
Yeah, I think if I get the question right, I think that understanding types of microorganisms is also really, really important. Doing regular profiling, and by that it's not just samples that are above alert or action, because that may give you an insufficient number of samples to which to fully understand the types of microorganisms that are present. But in particular, you want to know that there's not organisms there that are indicative of control breakdown. So if you think you contain water but you're finding gram negatives, if you think you've got good control over transfer of items into the facility but you're finding spore-forming bacteria or fungi, then that kind of information can be really valuable, that something is going wrong, you need to put some kind of corrective action in place. But once the corrective action's been made, you then may wish to maintain a higher level of monitoring in order to assess that that corrective action has indeed been effective, and then readjust as time goes on.
Excellent, thank you. I think we've got time for one more. In case of personnel monitoring for finger dabs, after every open door intrusion, how can it be managed for increased number of intrusions based on risk assessment?
I think the issue there is that every open door intervention presents a significant risk if we're talking about a grade A environment. So the first consideration is how do we design out not having to undertake those grade A interventions in the first place. So, you know, what barrier can we put in place? Can we fit glove ports and turn whatever we've got into more of like a restrictive access barrier system? And I think it's also more about understanding what the activities are, having undertaken airflow smoke studies, building up a picture of particle counts, understanding the time. It's not just, I think aseptics is far more complicated. It's, you know, we might get lots of zero finger plates, but it doesn't mean what we're doing is not presenting a significant risk to the product. So, and that's why I deliberately framed a lot of what we've presented today in terms of either non-sterile facilities or grades C and D. I think aseptic processing is kind of a subject of a webinar in its own right. So we do have to be careful, but the key thing is there's no such thing as a safe intervention, and we should be trying to design those out in the first place. That's the answer I can give, I think.
Great, thank you very much. Okay, so thank you very much, Tim, and thank you all for attending our webinar. I hope you found it useful, and we really appreciate these the questions that have come in and that you've asked. Any questions that we didn't get around to, didn't cover during our Q&A, I'll forward to Tim, and as mentioned at the start, we'll circulate these along with a copy of the recording as well. If you wish to catch up at any of our previous webinars or Tim's blog or regulatory posts and updates, please go to our website or keep an eye on our social media threads. We also offer a range of technical training courses designed for professionals across the industry. We've got several upcoming sessions, including those detailed on the screen, with more scheduled throughout the year. You can find full details and registration links on our website. Remember also, check our website for future webinars. Just to say thank you very much for attending, and have a good day. Thank you.
Thank you.